Hi all, this is Alan with Bothell STEM Coach, and today I'm starting a new series on what I'm calling challenging integrals. Now, these integrals are something that you should be able to do in AP Calculus, but they are probably a little trickier than you're used to seeing, and you'll probably see on the AP Calculus exam. So, as a challenge, I suggest you attempt to try this integral. You can do this integral with just u substitution, by the way. But you're just going to have to be a little clever with the u substitution. So I would pause it, try the problem on your own, and come back when you've gotten as far as you can. Okay. Now, the trick to this problem is there's a couple of ways you can think of doing it. You can try, the most direct way is probably to do this u is equal to 4 minus square root of x. Okay. This is maybe what you've tried, and I don't know if you got stuck. Du, the derivative here, the derivative of 4 is 0, minus, this is x to the 1/2, so this is 1/2 x to the negative 1/2. And so this ends up being negative 1 over 2 square root of x. Okay. Oh, there's a dx in here, I forgot. dx. Okay, you might be thinking, okay, that's not particularly helpful. But one thing you're allowed to do is I can rearrange and solve for dx. Okay, so I can have negative 2 root x du is equal to dx. Now this isn't helpful because my goal is to replace everything with u, and I have an x in here. Well, I can solve for the square root of x by rearranging this equation. I would have square root of x is equal to 4 minus u. And so I can plug that into here and get negative 2, 4 minus u du is equal to dx. Okay, and I'm going to go ahead and multiply out this negative 2. What this would end up being is negative 8 plus 2u du, okay, is equal to dx. And now let's substitute everything. This becomes the integral. All of this just becomes the square root of u. And the dx I replace with all of this, which is negative 8 plus 2u du. And if I sort of distribute it, what you'll have is you'll have negative 8 root u du plus 2 u root u du. Okay? And so these are actually, I can solve for this integral. This is u to the 1/2, so I just apply power rule. So this is negative 8 u to the 3/2 divided by 3/2. This here is already u to the 3/2, right? Because u to the first times u to the 1/2 is u to the 3/2. So this is plus 2 u to the 5/2 divided by 5/2, and then plus c. So this becomes negative 8 times 2/3 u to the 3/2 plus 2 times 2/5 u to the 5/2 plus c. This becomes negative 16 over 3 u to the 3/2 plus 4/5 u to the 5/2 plus c. And the last step, I just replace u with this. So this is negative 16 over 3, 4 minus square root of x to the 3/2 plus 4/5, 4 minus square root of x to the 5/2 plus c. And I'll do this as an exercise for you to show that the derivative of this actually does equal this, but it should work out unless I messed up on the math there. So it's an interesting use of the u substitution. This whole rearranging and plugging in and solving for terms that I don't have. Like, it's not the standard way that the u substitution works, but it is a valid way to do u substitution. Yeah. So hope you found that helpful. I'll see you in the next video. Thanks for watching the video, guys. Please leave a comment, like, or subscribe below to catch up more of the content. And see any links below. I offer free homework help on Twitch and Discord. See you guys in the next video.